Hello friends, welcome to another coding video. Today we will be discussing this problem of spiral traversal of a matrix. So let's see the problem statement. So we are given a matrix of m cross n elements. M is the number of rows and n is the number of columns. We have to return all the elements of the matrix in spiral order. For example, take this matrix which has the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So we have to return this vector, okay, which is 1 in this order, from here to here, from here, then here, then here, and here. Okay, in this way we have to return the uh, traversal. So it's a pretty simple problem. Let's jump to the solution for the problem. So we are given a matrix of size m cross n, and we have to give the spiral order traversal of this matrix. For doing so, we will be using 4 for loops. Each for loop will maintain a row or a column in the spiral order traversal. Okay, so we have to return a vector result which will contain the spiral order traversal. So let m be the number of rows. If the number of rows is 0, we have to return an empty vector, nothing to do much. If and let n be the number of columns in the matrix. So the gist of the problem is to compute the spiral order traversal and keep decreasing the size of the problem statement. So let's say when we calculate the spiral order for the outer most elements, after that we have reduced this problem into a smaller sub problem, right? Again we have to do spiral order traversal for this. Okay, so let's see how do we do that. Okay, so for traversing each of the rows or columns, we will be maintaining 4 for loops. Okay, one for each row. This for loop corresponds to this row. This for loop corresponds to this column. Okay, this for loop will correspond to this row, and this for loop corresponds to this column. Right? Let's erase this and start with the dry run of this problem. So we are maintaining a total of 4 variables. One is row start, one is column start, one is m, and one is n. Okay, so row start and column start starts from 0, and m is the number of rows, which is 4, and n is the number of columns, which is 5 here, right? So let's see how do we print, take the result in a vector, this first row. So we have to start from the row start. For this is constant here, and we have to print all the columns, okay, till the last column, and the last column will keep changing when we minimize the problem to a smaller sub problem, right? So here what we are doing is, for I is equal to column start, which is the current column at this point of time, so this will also increase, and the row starts and column start increases, and m and n decreases to minimize the problem to a smaller sub problem. Okay, so we'll start I from column start to the current number of columns. Okay, uh, and we push back the matrix of rs comma I to the result. So we are keeping this thing into the result. Then is this column, what it does, it's after doing this previous thing, we'll increment the row start. So is now row start is now 1. Okay, so we start from I is equal to row start to I less than m. So from I is equal to 1, I less than 4, we'll do this. So basically it will print these elements. How we are printing matrix of I, which is from I of I and n minus 1, and I runs from row start to the number of rows. Okay, so that is 1, 2 and 3, and the column is the last column that is currently in this problem. So this will print 4 minus 1 is 5 minus 1 is 4. So I is 1 4 2 4 and 3 4 it will print. Okay, now let's so after doing this we decrement the number of columns. So n will be currently 4. Okay, so that is up to this matrix. Okay, and the rows are, so the currently reduced problem is this one. Okay, now we have to print this row in reverse order. So we'll start from I is equal to n minus 1, which is 4 minus 1 3, to I greater than equal to column start, which is 0. Okay, I minus minus, and we print the last row that is currently there. For 4 minus 1 is 3, so we'll print 3 and 3 3, uh, 3 2, 3 1 and 3 0. Okay, since row start is still less than m. Okay, in the last thing we have to then this m is decremented, so m now becomes 3. Okay, so that is the sub, it is minimized to this matrix. So in this one column start is less than still less than n, so we print these two. Okay, in reverse order. So I runs from m minus 1, that is 2 to greater than equal to 1. So 11 2 2 2 0, sorry, and 1 0, right? So this prints this one. After that the column start is incremented, so column start will become 1, right? So that is the problem statement is minimized to this one. Okay, and similarly we keep doing this. Okay, to print all the rows and columns in spiral order, right? You can do a dry run to this problem to understand why this condition is necessary. Okay, this condition and this condition. For example, when we are processing, we have processed these things and we are processing this row now. Okay, so this row will be processed in this for loop which prints 7 8 9. After that since row start will be here, row start will point here, and m is also here. Okay, so uh, this nothing will be executed, and in this, since row start is not less than the number of rows currently, so we don't execute this. So this condition helps us preventing this row from being written in reverse order, right? Okay, that's it. That is the reason we are having these conditions. So what is the time complexity for this problem? Time complexity is basically we are traversing all the elements in the matrix once. So the time complexity is order of m cross n. What is the space complexity? So if we consider the return values, then it is order of n, m cross n, otherwise it is order of 1. Order of 1. Why? We are only using constant extra number of variables, nothing else. M, n and row start and column start, nothing else. So the time complexity is order of m cross n, and the space complexity is order of 1. Hope you enjoyed watching this video. If you like the video, hit that like button And do subscribe to my YouTube channel for more such videos. I'll be regularly uploading videos from now onwards. So do subscribe to keep notified, and do press that bell icon to get notifications. Thank you.